Hello, Gen Chem friends. I hope you are doing well today. So we introduced in the previous video the ideal gas law, otherwise known as PIVNERT, PV equals nRT. We introduced that law and how to do calculations with it. In this video and in subsequent videos, we're going to talk about some applications, some practical applications of the gas law. One of which is being able to rearrange the ideal gas law to solve for a gas's density. And if you remember, density mathematically is equal to mass over volume. If we take that definition of density and remember that PV equals nRT, if we take that equation and do some algebra, specifically if we divide both sides of PIVNERT by V and by RT, then we get an expression of PIVNERT where we have N divided by V on one side and everything else on the other. And that's promising, hey, we've got volume in the denominator just like density. But to solve for density, we need a mass. And right now we have that ideal gas law solved for not mass over volume, but moles over volume. Well, we can easily, if we know the identity of a gas, we can easily take the expression of moles multiplied by molar mass to get moles. So if we can take moles multiplied by the substance's molar mass, which if we know the substance, we can calculate from the periodic table. Multiplying those two things together gives us a mass, gives us grams. So we can then solve for the ideal gas law in terms of mass and volume by doing a little bit of algebra rearranging. So we can say that the density of a gas can be found by knowing a substance's pressure, molar mass, and temperature, along with the gas constant in liters atmosphere mole Kelvin. So this rearranged equation of the ideal gas law for density is one that you need to know for the upcoming exam. Let's do an example problem of that using that equation. So in this problem, I ask you for the density of carbon tetrachloride at a particular pressure and at a particular temperature. You think, density. Okay, well, I've got a pressure here. I've got a temperature. I didn't give you a molar mass, but I did, let me get my little pointer here. I did give you what the substance is, carbon tetrachloride, CCl4. And so from that chemical formula that you'd be able to get from the name, you can easily calculate the molar mass of that substance, which is what's done down here. We've also made sure to convert our temperature, which is in Celsius, to Kelvin. And since our gas constant is in liters atmosphere mole Kelvin, we need to convert our given pressure into atmospheres using the appropriate conversion factor. So we now have a pressure, a temperature, the molar mass, the gas constant. So we can now take that rearranged ideal gas law equation and solve it for density, plugging in the appropriate values. And we see that our units cancel, our atmospheres cancel, our kelvins cancel, our moles cancel, and we're left with a substance that has units of grams per liter, mass over volume. So those are appropriate units for density. Doing that multiplication and division should give you a final answer of 4.42 grams per liter. So the ideal gas law in a rearranged format can be used to solve for the density of a known gas. In the next video, we're going to talk about how to use the ideal gas law to solve for the molar mass of an unknown gas.